going to be solving rational equations now. Now, rational equations, of course, would have an equal sign, which makes them different from the ones that we were working before, where we were just simplifying expressions. Anyhow, when you are solving rational equations, there is a possibility that you could have extraneous solutions, which are false solutions. So what would make a solution extraneous in this case would be if it makes any of the denominators zero out. So you do all of your math, you get an apparent solution, but if you put it back into the equation, it makes one or several of your denominators equal zero, then that one is not really a solution and you would have to discard it. All right, so the method we are using today is called cross multiplication. And you can cross multiply only when you have one fraction equal to another fraction. So in our first example here, you can see we do have one fraction equals another fraction. So I'm going to cross multiply. I'm going to multiply the first numerator. Wow, that was really big. Oops, having some issues now. Okay, so the first numerator times the second denominator. And that'll equal the second numerator times the first denominator. So we're setting those cross products equal to each other. Okay, now to solve this turned into just a linear equation now. So I'm going to distribute the 5. So give me 5x minus 10 equals 3x plus 6. And since it is just linear, my technique for solving it is going to be to gather my x's on one side of the equation and gather my constants on the other side of the equation, and then divide. So I'm going to make my x's on the left by subtracting 3x from both sides. So that would give me 2x here on the left. And I'm going to get my constants on the right by adding 10 to both sides of the equation. So that would give me 16 here on the right. And then I would divide both sides by 2. So I would get x is equal to 8. All right, as I mentioned before, it is possible that we could have an extraneous solution here. So if this value that I found as my x makes at least one of the denominators equal 0, then it's not actually a solution and I would have to discard it. So the way I want to figure that out is I want to actually take the denominators that we had in the original problem and write an inequality where I say, okay, well, that denominator cannot equal 0. And I'll do that with the second one as well. That denominator cannot equal 0. So then I can solve these two inequalities to find out what values of x would not be allowed for this equation. So that first one would give me x is not equal to -2. The second one would give me x is not equal to +2. The answer that I got was x equals 8, which is not either of those restricted values. So therefore, that is my solution to this one. All right, now you try this next one. And after you've finished working it out, you can highlight this space over here on the document, and it will tell you what the answers are, so you can check and see how you did.